Welcome. Thank you, everyone, for coming tonight. So I'm going to talk about watersheds, why we measure water quality, what is community water monitoring, and community water monitoring data and the integrated report, study design and quality assurance, and some examples of community water monitoring projects. So first of all, what is a watershed? And maybe most of you know this already, but a watershed is an area of land based on topography that drains to a particular water body. And many times we talk about either subwatersheds or HUCs, HUC, hydrologic unit codes. So I just wanted to take a moment to explain what we're talking about when we say that. So USGS came up with a hierarchical numbering system to identify watersheds and subwatersheds. So the first two digits of the number are the region of the United States. So our numbers always start with 02. Then the first four digits in New Jersey, we have 3 regions. So all of our watersheds start with 0202 or 0203 or 0204. And as it goes up to being 8 digits, you're kind of talking about a smaller scale, and 11 digits, you're talking about a smaller watershed, and then down to HUC 14s, which is the smallest unit that we usually talk about. And we usually interchangeably use the word subwatersheds, or in the New Jersey DEP's integrated report, we also use the word assessment units. So why do we measure water quality? So we want to identify pollutant sources and protect or restore the uses of our water. So the uses of water are swimmable, drinkable, fishable, and aquatic life. And these are required by the Clean Water Act. And in addition, the Clean Water Act requires states to make an assessment of whether our water meets those designated uses. So does it meet swimmable, drinkable, fishable, or aquatic life? And that list of the waters that are impaired or that don't meet those uses, and just a list of the water quality in all the waters of the state are combined into what's called the integrated report. And this is something that we do every 2 years and submit to the EPA, and as well is available to the public. So each report includes an intensive assessment of one of New Jersey's 5 regions, and we rotate around to the different regions so that each region is focused on every 10 years, but the entire state is assessed every 2 years. So what type of water quality data is collected? First is physical conditions, which includes like stream depth, flow, temperature, chemical characteristics, such as the concentration of phosphorus, nitrogen, dissolved oxygen, things like that. Biological conditions is the number and type of living creatures, and bacteria is also usually in that category as well, and the condition of the habitat. And the fourth type is identification and reporting of algal blooms, including harmful algal species. So what we are learning about in stream school encompasses these two, the physical conditions and the biological condition. So what is community water monitoring? Is it volunteer monitoring, citizen monitoring? Is it real science? Is it fun? All of these are yes, except the just for fun. It's not just for fun. We hope that it is fun for you, but it is real science, and it is real, and it is useful for improving the environment. So our definition is community water monitoring is the collection of scientific water quality data by concerned citizens working in partnership with professional scientists and government decision makers. And the key words I like to focus on is it is science and it is working with decision makers. So we have a purpose to why we are collecting the data, and it is to make scientifically informed decisions to improve our water quality. So our objectives are to increase the, from the DEP's perspective, is to increase the quality, quantity, and spatial extent of the data produced by community water monitoring programs, such as what you are volunteering for. This will aid in the assessment of the statewide water quality conditions, and that will help us support science-based decisions to improve the water. So as Erin mentioned, we work between the Watershed Institute and the Department of Environmental Protection on a program called New Jersey Watershed Watch Network. It's funded by a grant from DEP to the Watershed Institute. And just to clarify, there's like communication and working together between the department and the Watershed Watch Network. And we usually communicate with the group leader of your community water monitoring group, and that group leader directly interacts with these, whether you have staff or volunteers of your group. So there's benefits to participating in the Watershed Watch Network. We aim for it to be a one-stop shop for New Jersey community water monitoring issues. And we've created a clearly defined pathway for using your data and accepting your data for the appropriate use of your data. Also, information sharing between volunteer organizations. You can learn from each other, and also providing training and workshops on topics that are of interest to you. So Erin had surveyed the different organizations throughout the state to identify what monitoring groups are out there. And I believe soon she will be updating this, this inventory. But the first version of the map, which is on the Watershed Watch Network website, shows that there are 31 active monitoring groups, 8 more that might be interested in developing monitoring programs, and then 10 service providers. So for example, in DEP, we provide training, and EPA provides equipment loan program, and some of the other groups also provide either technical assistance or sometimes sample monitoring assistance. So when you decide that you're interested in monitoring water quality, it's really important to develop a study design and establish parameters for your data quality. So we need to know, and you need to know, why are you monitoring? How are you going to do your monitoring? And then what are you going to do with the data? So in your program design, you want to define the reason that that you're monitoring, like what questions you want to answer, and the project scope. So what is your geographical area, and what type of information are you going to be collecting, and who is going to be using your data, and as well as what your budget and scalability is. And then to the center of the slide, then after you've answered the other questions, you need to decide on the technical design. So where are you going to monitor? Who will be doing it? What parameters will you be testing? what is your timeline? And your data quality objectives and methods, and how you are collecting your data. And then to the right, then what are you going to do with your data? So where are you going to store your data? How are you going to ensure that the data is accurately transcribed from collecting it, whether you're using paper or like a digital, like a tablet or something like that. How you're going to summarize and analyze your data, how you're going to interpret the data, and how you're going to share and communicate your data. So with the Watershed Watch Network, we have developed tiers, data quality tiers that explain, depending on the quality assurance that have been instituted in collecting your data, what is the appropriate use of your data. So tier 1 is the easiest with the least requirements for quality assurance, and that would be for educational uses. Tier 2 would be targeting, and tier 3 is regulatory. I'll explain those in a moment. So tier 1 is educational. So by that we mean it's for community education and municipal engagement. And this will require a study design. So you are setting forth what you're doing and documenting your methods and your time frame. And an example of this is with the New Jersey Watershed Ambassador Program. They often provide what's called an environmental stewardship training, which is like a half-day program where you're doing something very similar to what we're going to be doing, but it's only a half day. And so it doesn't go into the depth that we're going into with Stream School. With tier 2 level data, we call that targeting. And tier 2 data is used for, it can be used for education, like just the same as tier 1, but in addition, it can be used for project-specific monitoring and water quality report cards. So for example, best management practice effectiveness monitoring, or targeting the installation of BMPs. Excuse me a second. As well as targeting where additional monitoring may be needed. And tier 2 requires, for quality assurance, it requires a data documentation and quality assurance measures and approval of your quality assurance project plan at the tier 2 level. Tier 3 can be used for the tier 1 and tier 2 uses, but in addition, it can be used for regulatory purposes. So this needs the highest level of quality assurance because regulatory actions could be taken based on the data, and we want to be sure that that we are very confident in that data. And using the data for the integrated report is an example of regulatory use. So this other examples are Category 1 designations and development of total maximum daily loads to address impairments. And the data quality requirements include data documentation and quality assurance measures, and approval of your quality assurance project plan at the tier 3 level. So again, it's very, if you, this training is to train you at the tier 3 level to do your project at the tier 3 level. And so we want to be sure that you understand that it is very important that that you're following the training and that we are training you thoroughly so that we can be very confident in your data in any way that we might use it. So I know I've said quality assurance project plan. So what is that? So that is a written document that outlines the procedures for a monitoring project that ensures that the sample participants, that's you, collect and analyze the data and the data they store and manage, and the reports they write are of high enough quality to meet the project needs. So they're, as I gave examples of our tiers, data projects are valid, they just have different uses depending on what the project's goals are. So by having a quality assurance project plan, you're taking that study design to the next level. And some examples are that we want to prevent errors before the sampling begins by thoroughly training you and doing the accreditation to check that the volunteer competency in the, performing the stream assessments. And then quality control measures are implemented to correct errors after sampling has occurred. So for example, is taking 10% of the samples to be re-identified in a lab, or auditing where I'll come out and audit you as you're sampling. And the quality assurance project plan has to be approved and signed before the data is collected. So with our macroinvertebrate sampling, for our quality assurance measures for tier 3.1, which is what you're doing, but just so you're understanding how everything fits together. For tier 3.1, we do identification of the macroinvertebrates while we're right there at the stream. And these are identified at the order or family level. And Erin's going to explain that in more detail in one of her presentations. There is a tier 3.2, and I've just put that kind of in gray because we don't have anybody in the state actually doing that. But that would be identification to the family level. And then tier 3.3 is when the macroinvertebrates are preserved and identified at an approved lab. And these get identified down to what's called the lowest practicable taxa. So sometimes that's genus and species level, but sometimes they're not able to identify it that down to species. And so that's why we say it that way. So when we collect the macroinvertebrates, we use what's called an index. So we kind of input those numbers that we came up with after we look at the macroinvertebrates. And it's called the volunteer index. And excuse me a moment. And we will get three choices. We'll get either showing that the stream has a healthy biological community, and undetermined, so like that's in between. We can't quite decide whether it's good or bad, or stressed. And then with the other two levels, there are with the other two tiers, there's 4 levels. So excellent, good, fair, and poor. So for accreditation, this is required for each individual volunteer to collect the tier 3 habitat and biological data. This must be completed before you do your data collection, and then renewed every 3 years, assuming that you are enjoying yourself and continue to participate, which we hope that you do. This will include the showing that you know how to identify the macroinvertebrates, the bugs, by looking at 50 preserved organisms. And this is open book. You can use any kind of ID keys. We'll show you how to do this, and you'll need to get 90% to pass that accreditation. And then on the right side there, the field accreditation, you need to demonstrate that you're able to correctly complete the physical and habitat part of the data sheet, the rapid bioassessment protocol, and collect the macroinvertebrate samples. In addition, at the tier 3 level, we require performing replicate macroinvertebrate sampling at 10% of the monitoring sites per year. So that means that 2 macroinvertebrate samples will be collected, but not an additional habitat assessment. This will make more sense as we are out in the field and can kind of demonstrate that. And this data gets submitted, the original data as well as the replicate data gets submitted to the water quality portal, which is abbreviated as WQX. And there's just a specific code that you put in there that says that it's a duplicate, and so that when DEP looks at your data, they're not counting like that the stream was had 2 samples taken. It's just kind of to see if we're training you accurately, and if we need any follow-up on that. And then we also do field audit, which is I just come out to while you're sampling and just kind of watch and can answer any questions, but mainly just you've already been trained, but I'm just it's kind of like just a checkup at 5% of the sites. And once you're sampling, then I'll be reaching out to the group leaders to schedule that. So an example timeline for biomonitoring would be, and the first step has happened already. Erin has met with the group leaders for technical assistance. We're in the midst of helping develop QOPs. They've done outreach to you to recruit volunteers, and right now we're in the step of stream school and accreditation. After that, you'll get out there and do the fun part, which is collecting the data. As you go along and you're collecting the data, I'll be coming out and just auditing occasionally. Then you'll have the data, and that's a really important step too, that you never want to neglect that part. It's very important to check that the data is collected and entered into the database correctly. And then the last step, very, very important, is to share the results. So with your own groups for education purposes and with DEP, so that we can use your data. Also note that QOPs are valid for 3 years. And now I'm just going to give a few examples of some community water monitoring projects. So like what you're being trained in this stream school is training for biomonitoring. And one of the fun bugs you'll be learning about this week. Another type of community water monitoring is monitoring for harmful algal blooms. So we have a number of groups that are using little meters that measure the phycocyanin in the lakes and report that data to DEP. And even if you don't have the meter, you can learn how to visually recognize what it could very likely be a harmful algal bloom, and you can report that to an online reporting, and then DEP follows up on those reports. Another type of monitoring that volunteers can participate in is monitoring for bacteria or pathogen indicators. This also can be called microbial source track down. And one example of this is that Clean Ocean Action does bacteria sampling in the Navesink, and with the goal of restoring shellfish harvest because there's too much bacteria, and that prohibits the harvest of shellfish because it wouldn't be healthy for people to eat that. And the idea is to identify where problems are happening and fix them. So not to, I know we said that the, we have the regulatory, excuse me, regulatory level of data, but mainly the goal is to find and fix any problems out there as collaboratively as we can. Another example of a community water monitoring project is our impacts of road salt on freshwater project with the Watershed Watch Network. And the illustration just shows the map of some of the results and what the test strips look like as they're when they're monitored. And winter's over now, but if you're interested, I think some of you may have participated in this already. So thank you. So community water monitoring groups have contributed data to the integrated report. For the integrated report, we use all readily available data. So the way we do that is we collect data that is in the water quality portal, which is a database. We get millions of data points from that and analyze that data. It also, we get DEP has continuous data, USGS has data, beach conditions, shellfish harvest conditions. All that data is analyzed and interpreted. The data is, after it's downloaded, it's evaluated to ensure that it meets the established data quality requirements according to the methods document. And there also has to be a minimum parameters. So certain parameters tell you whether a designated use is being met, for example, swimmable or drinkable. And they're aggregated. Remember at the beginning of the presentation, I talked about the HUC 14s or the subwatersheds. So the data is aggregated in those sections, in those water bodies of the state. And then for each parameter, they're compared against New Jersey DEP's water quality standards and to see whether the water meets those standards or not. And Erin put together this chart for the 2018-2020 integrated report where the different data came from. And community water monitoring is under the volunteer category, and 1% of the data came from volunteer groups. So it's used, it's very helpful in the report. We have a little more detail on that. So these maps illustrate the subwatersheds or HUC 14s where data collected by community water monitoring groups as well as the AmeriCorps watershed ambassadors were used to inform the 2020 integrated report. So for over 10,000 data points from 11 organizations were used for the parameters illustrated. I'm going to go through each one. So for biological data, the tier 3.3, remember that was the samples that are sent to a lab for identification. So those are shown in light green on this map. And the tier 3.1, which is what we're going to be trained on this week, is in light purple. And you can see, many areas of the state have community water monitoring and AmeriCorps contributing that data.